Good morning, I'm Dror Helper. Good afternoon, I'm Dror Helper, and this is the Working with C++ Legacy Code session. And before we start, I think an introduction is in order. As I said, my name is Dror Helper. I work as a consultant in a company called CodeValue. I've been developing software for more than a decade. This has been a C++ room. I guess I'm not alone, right? And I've been using test-driven development and clean code since 2008, I guess, where I learned about those. And I've been teaching that ever since. I help developers write better code and have encountered numerous legacy code situations. I'm also a Pluralsight author. I just released 2 courses in C++, unit testing with Catch and deep dive into mocking in C++ with Google Mock. And I suggest you check them out. I also have a blog at helpercode.com where I write about anything I find interesting. And I have Twitter, the helper, so feel free to tweet, say what you think. We exclusively develop in C++, just C++, nothing else. No one? .NET developers in the crowd? Java? The rest are product managers, I guess. I'm doing, currently at my job, I get to consult in Java, C++, and .NET, and that way I can draw lines between the similarities and the differences between them. And I think we got it better in C++, to tell you the truth, and I'll explain why. But before that, we all came to talk about legacy code, right? What does legacy code means? Does anyone has a good definition of legacy code? I'll tell you my definition. It's the feeling I get at the bottom of my stomach when I look at the code base and understand I need to work with it, right? It's a very emotional term, legacy code. It causes fear and distrust. And, well, you know you are not going to have a good day when you see that code the first time. And we all know we're probably talking about this old code written in the days of the dinosaurs by someone using bad practices and obsolete methods, right? Not a good developer like everyone else in the room. And we probably ate this guy as well. But there's no clear definition for legacy code. The only thing close to a definition we have is what Michael Feathers wrote in his book, Working Effectively with Legacy Code, which if you haven't read before, you should, where he says legacy code is code without unit tests. And I get it, but it's not really a full definition. I wish there was a word, a sentence I can say about legacy code other than legacy code that will explain exactly what it means. Unfortunately, we don't have that. But what I do have is I notice a few properties of legacy code. Some things that are true for every single code base I got to look at, which was, in an essence, legacy code. The first of which is that it is no longer engineered, just patched, right? When we start a new project, we have an architecture team or an architect who come up with this amazing design, and then we build, and we take the components and break them down, and we have lengthy conversations about the best way to implement the code, right? And then we ship the product and forget about that. And the next guy in line, usually it's someone else, get to patch the code, because what I notice developers do with code that they have no idea what happens there with legacy code is that they put a breakpoint somewhere in the code, run line by line until something that looks similar to the bug they want to fix or a place to put the feature in place. And then they write the code, immediately compile, build, and commit, and run away, right? And this is the case with legacy code. Another thing about legacy code is that it's very fragile. It's easy to break legacy code, especially after a while has passed, after a few years. If you get this code that was written 8 years ago using old C++, it is almost impossible to change anything without breaking some functionality. And this is the good case scenario. Because the best case scenario is you break the functionality, but you're not aware about it. I had a client, a customer called in the middle of the night, something very crucial, important in his process stopped working. And after a lot of digging, log reading, and debugging, we found the problem. It was a change that was made 2 months before that. They changed the code ran for 2 months, and only after 2 months, someone noticed that there's a problem. And that is usually the case, and that's why we fear this code so much, because we don't know what will break. We are not even sure whether or not we'll be able to catch the bug once it happens. The next thing about legacy code is that obviously it was written by someone else. Last year in NDC, anyone was in NDC Oslo 2016? Okay, me too. And I went to a session by Caroline Clever, in which they did a survey about legacy code. As developers, for the definition of legacy code, 3% of those developers said legacy code is any code written by someone else. And I laughed, because that's like a very funny definition, and then I thought about it, and it's very true. Because what usually happens with legacy code is that the person who wrote it and understood what he's doing left. Either he moved to a new project, either he moved to a new company, and there's no one to ask what to do. There's no one to tell me what was the original thoughts, the original decision he made when implementing the code, and which make it easy to break his code because I have no idea what he had in mind. Now, in some cases, some rare cases, I managed to find this person. He has no clue because he forgot. We're talking 5 years ago. He has no idea what happens there. I barely can remember what happened last month. And that's a problem, because usually the people responsible for maintaining legacy code are not the one who wrote it. And lastly, and very importantly, legacy code has users. And those users are the sole reason you came to the session. Because legacy code without any users, you can erase immediately and forget about it. But usually, the code we're working on, someone really, really cares about it and want to use it. And he really needs it to keep on working. He needs the bug fixes, and he needs the new features. Some of the time, they even got used to the bugs, and he need the same bugs to continue working in that specific way because they found some method to work around them or with them, and you can't change that because they pay money, or they need it in order to make money, and so we need to remember those users whatever we do. So, having defined some properties of legacy code, I have good news and bad news. Starting with the bad news. Everyone here works in C++, right, to some degree, which means that you might have a problem, because in C++, there's quite a lot of legacy code in relation to other languages. I don't have any numbers whatsoever, but I have a feeling that more than in Java or .NET, the reason being that C++ has been around for many, many years, and a lot of systems were written using C++, and so we have quite a lot of legacy code there. The second bad news for you, which you might have known already, is that you're probably working with legacy code right now, right? Because in C++ these days, either you get to implement some cool algorithm or multi-platform voice over IP thing, or you're working with legacy code that you need to keep on maintaining and fixing. And the last thing is that with C++, it's very easy to make very big mistakes. Memory allocation problem, buffer overflows, you name it, you all been there. And that makes it hard to work with legacy code because we can break something in a very critical, problematic way. But I have good news for you. The good news is that working with C++, you have quite a lot of power in your hands. And C++ enabled me to do things with legacy code that I can't do with Java or .NET. In fact, when going into Java or .NET places, I wish I had some of the features of C++ that enable me to fix and improve legacy code. And I'll show you a few of them. So what can we do with legacy code? 3 simple steps, simple to say, not to do. First thing is understand what the code does. Seems trivial, right? But we all know that sometimes we feel as if it's better just to jump into the code and start fixing things before fully understanding what it does, and sometimes it's very hard to understand what the code does. Reason being that, again, we don't have anyone to ask, and there's quite a lot of it. But in order to work fully with legacy code, we really need to understand what it does beforehand. I've been in 2 companies in which, as part of fixing their existing problems, I drew diagrams, workflow diagrams, of how the system works. And it was the first time anyone in that company really understood what the system does. And that's a shame that you need a consultant to do that, but what can you do? And in fact, in one company, it was so successful that it took that diagram and continued implementing new features in other platforms based on my diagram that I draw just to fix a bug. So you need to understand what happens. Once you get a clear understanding what that piece of code does, now you need to make sure that it keeps on doing that, doesn't break, which is also very trivial to say, very hard to do. Because there are users that want your code to keep on functioning the same way. And lastly, once I achieve those 2 points, the next order of business is to start improving. Now I can refactor code, now I can make fixes, because I know what the code does, and I can fix that. This is the end of the talk, right? Don't need to know anything else. Now, before that, there's one tool that helped me do that. Although I am pretty biased, but I noticed that after I'm drawing the diagram and use the static analysis tools and I understood what the tool does, what the code does, and I got a few people to talk to me and explain what they wish it did. Writing unit tests can really help me here. Because unit tests help me, first of all, define what the code does. I need to write code that executes it. And by defining what the code does, I learn things about it. And once I have a unit test in place, I can debug it instead of taking the whole project and running it and trying to debug the specific scenario I'm trying to implement or test here, which in most big system, enterprise system, is very hard thing to do. Sometimes I don't have the environment to get the whole project in place. So I want to run just a few points of it, a few pieces of it. And once I have those tests in place, I know I can change the code without breaking it. It's as simple as that. And this is what a unit test looks like. Anyone here ever used Google Test before? OK. That's the same amount of people I get when I ask about unit testing in .NET. So that's fine. Unit test essentially is a method. It's as simple as that. It's just a method that I get to run my code in. And that's it. And everyone here knows how to write a method. And right. And in this case, I'm going to show the demos with Google Test and Google Mock, not because they're better or worse than other unit testing frameworks, just because in this specific environment, it's easy to talk about them. They are widely used, easily acquired. If you want to learn about other unit testing framework and mocking framework and hear what I think about each and every one of them, I have another session tomorrow. So what do we have here? Usually in the C++ unit testing, there's a macro, which is this guy over here. Let me try. That is the test macro. Basically does 3 things. First of all, define a new method. This is like writing a new function. The second thing it does is that it creates a class in the background. If you go and dive into that code, you'll see there's a class created here because we want a class around my method. And the last thing, it makes sure that when I run the whole project with the unit test in, the unit test will be executed. So essentially, that's a platform for running code. That's it. Nothing more, nothing less. Other than that, I have here this is also known as the test fixture name, but well, we're C++ developers, grown-ups. This is the class name that will run the test. And the second thing over here, here we go, is the test name. And the test name is what it's called and what it does. Usually, I'll give it a good name, not this thing I wrote here. And in the middle is the important bits. The important bits is the actual code I get to execute. This is this part over here. First, I'll initialize whatever I need to initialize, and then I'll run the code I'm trying to test. And usually, in the end, I have another macro, depending on which unit testing framework I'm using, that will check the results. In this case, I'm checking that when I call night.say, I'll get back ni. And if that's, in fact, is the case, the test will pass. Otherwise, the test will fail. It's as simple as that. And that's basically is how you write a unit test in C++ using Google Test. But it's not as simple as that, because no one ever wrote code that looks like this, right? We have things in our code called dependencies, other people classes. We have server and databases and third-party libraries that are executed and run as part of our code. And usually with old code, we have more of those. Usually the code is not well structured. There's no clear definition. The classes are not divided. We have a big mess. And taking a big mess and trying to test that is nearly impossible. And so I need to make a few code changes, and then I hit a problem because the code has dependencies, and if I needed to change that, I'll most likely 78.3%, as they say, 33% of all the statistics are made up, as well as this one. So I'll probably break the code if I try to change it just to test it. And if I'll break the code, I know one thing for certain: I'm not going home today. I'm going to stay over the weekend or late at night to fix the problem I've just created. And that's not a good thing to do. I don't want to do that. And then, so I need to find a better solution. And when usually I have this sort of a problem, I always look for a wise man who already solved that kind of solution. In this case, Jim Carrey, who said, "My focus is to forget the pain of life, forget the pain, mock the pain, reduce it, and laugh." And obviously was talking about unit tests. Because in unit tests, I have two problems I need to solve. I have a sensing and separation problem. When I write a unit test with some sort of dependencies, the first problem is that when I run the code, in this case, the left side, send email to user, an email will be sent to the user, and I have no way to verify it actually worked. This is a sensing problem. There's no code I can write to make sure email was sent. I'm not going to poll my email account, my inbox, in order to get to know if the test passed or failed. And I also have a separation problem. I have very important kind of logic down here. Unfortunately for me, there's something in the way that is going to throw an exception or crash in some amazing, spectacular way, and so I don't get to the code I need. So going back to Mr. Carey's suggestion, I'm going to use mock objects. And mock objects, in a way, is something that every single developer here knows how to write. Anyone here ever used a mock framework, a mocking framework? The same. Some people didn't raise up their hands about the Google test, just raised their hands up, which is strange, but okay. Essentially, it's something everyone here knows how to do. Let me ask a different question. Who here ever called a database? Raise your hand. Who here ever called an external service? Raise your hand again. You didn't. Although no one here ever called a database, I say it carefully because this is a C++ room, and I might have some people who actually wrote database logic here. But we don't call database. We call a class that does the actual thing of calling the database. And in fact, mocking that class is just a method of inheriting that class, overriding all of the method, and I got a fake object. That fake object is, in essence, a class that does absolutely nothing. And that class that does absolutely nothing can be used in a test in order to get all the things I don't like in the test outside of my test and isolate the code I really care about, the logic I'm trying to test. And then I get to decide in a specific test what I want to do with it. Now, we can write those by hand. We can just inherit any single class we want and override the method, write a bunch of code. We're developers, we know how to write a lot of code, not just this simple, trivial code. Unfortunately, that's not a good idea, because once I start writing code just for the tests, and every test needs a specific environment and a different kind of behavior, I'll end up with a lot of code in my tests, which I need to maintain, and I don't like that. And I might even write a few bugs on the way and break something. And I don't want to write a test to test my test. So I'll use a mocking framework. And this is how I'll do that using Google Mock. Now, in C++, unfortunately, no reflection yet. And so I'll need to inherit the class, in my class, the fake REST API client. Here I have a REST API client. And in Google Mock, I'll just override the methods by using mock_method with some number after it in order to create an override method of that method I'm trying to change. Now, it takes a while, but you know, everyone here saw worse syntax. It's not the worst I can do. Essentially, the macro, the number is how many parameters that method has. This is the name of the method. This is actual. This thing will be converted to a new method overridden in the background, compile time, of HTTP post, which returns no argument and have 2 arguments of type reference to a string, to std string. The same here goes here with HTTP get, returns a string and get and received 1 string. Okay, any questions? So far, so good. How do I use those classes now that I have them in hand? Let's see a small demo. So basically, here I have a distributed calculator. I always say that in unit testing, we like to show calculators. They are very simple to explain. Functions don't look like the real code, so I use a distributed calculator. That calculator have a database in which it gets the data out of the database. It will return a tuple with 2 numbers. And then I'll stick them together using some string magic and call the client, an HTTP client, real HTTP client, with HTTP get and get a result back out, convert it to an integer. That's very naive things to do, but let's say it works, and that's it. Now I want to test that code. And I have 2 problems, right? I have a database in place and I have a client in place, and I want to remove those. So using Google Mock, I can remove them. And that's very important, by the way. All those mock objects, I just write them in the part of the code that is the test, not in the real production code. And if I go here, I have the fake client. To make my life simpler, I'll just use the mock method for HTTP get, which is a virtual method. And I have the fake data access. And here it's a const method, so I mock a const method of get data, and that will return a pair of 2 ints, no parameters, and that's it. Now we can write a test. How can I write a test? Very simply, here we go. This is the test. We'll go line by line. As I said, I'll mark it as a test, so I can run it now. And I have a distributed calculator test, whatever. I'll calculate, return 2 valid numbers. Someone will call the server. So in effect, I'm doing 2 things here. First of all, I need to make sure that the database returns 2 valid numbers. Second of all, I want to make sure that the client was called with the right parameters. And using Google Mock, I can use this macro, expect call. That's my way of telling it. I want you to expect that method to be called. For the fake data access, the method is called getData. And always, no matter how many times someone will call you, just return the data. What is the data? 2 numbers, 1 and 2. And then I'll create the fake client with some dummy URL. I don't care which, because I'm not going to actually execute it. And I write another expect call, the same for that client. And when HTTP get called with this specific parameter, I expect it to happen at least once. And for the test not to crash, I'll also return the number 3, although in this point, I don't really care what numbers come back, because testing this specific number is useless. I just told him to do that. And if we'll run this code, you can see what happens. We get here to the calculated test. Now, we have here the data access. I'll just, this data access inherit from the real one, but in fact, this is a gmock const whatever, data access. This is my fake class I just created. And if I'll jump slightly on DOS type, there's the fake client called with HTTP get, and I'll return the result 3, which I don't care about. In this point, the test just ended. Whatever happens after this point is useless to me, because I just told him what to return, right? This is the magic of fake objects. And what happens with Google Mock is that once you go out of scope, it will check whether or not what you just told him to happen really happened. So in effect, when I go out of scope, it will check that this method was called at least once. And if I run it all the way to the end, we can see the small V mark here telling me that it worked. If this wasn't the case, if I'll change it to at least twice and run it quickly again, I can find the, I'm using the sharper for C++ in this case, but you can run it in command line as well. We can see that it failed. It says too few actions specified in expect call happened. You expect it to be called at least twice, but it only was called once. So you have a bug. And this is my 30-second introduction into mocking. There's quite more to that, but that's the basics. So now you know how to fake external dependencies, which is very useful. But obviously, this is still not the big picture. This is not the whole story, right? I just show you a very trivial situation, which in legacy code will probably not happen. In legacy code, things are more complex. And I've just used dependency injection. I use the constructor to pass the dependencies in, which also doesn't tend to happen in legacy code. Usually, I need to find a way to somehow push those fake objects from outside to the inside of the class. And I don't know how much code you saw that actually does that in C++. But if it's as simple as just creating a new constructor that get all the dependencies instead of initializing them in the constructor inside, well, I'll just override the constructor and I'm done. If it's the matter of just doing something called function or property injection, which is create this hole in my method, a method that is set client or something like that that I can call, maybe that's a good solution, although it has some problem with it. But most of the time, it's not that simple, right? Most of the time, I need to work extra hard. Also, you might have noticed that I gave myself a few discounts on the way. My class was overridable, right? All of the methods in the classes I've just faked. If we go to the real classes, here we go, where are you? The REST API client has a virtual method. How many of you wrote virtual on every single method you ever written? Right? It's not something we do. And it's not always this way. There are, in fact, several dependencies which are harder to fake, which Google Mock won't work for you, because it can't override the method. If we can't override the method, we have a problem. And there's a group of those kind of dependencies, the first of which is methods which are not virtual. The second of which is classes I cannot or find it very hard to inherit, right? That's C++. We can do whatever we want. There are several tricks in C++ that will enable me to make the class impossible to inherit, right? I can make the constructor private. I can make the constructor very difficult with a lot of dependencies. There are quite a few of those. Static methods. Static methods cannot be overridden because they do not belong to any class. And singleton goes to the same kind of place. In singleton, I make sure that no one can override my methods, because what's the purpose of a singleton if someone can change the behavior? And well, internally instantiated is the most common situation, which in the method someone calls new and create a new instance, which means that I can take the fake object from outside and shove it into my code. And lastly, heavy classes. Heavy classes are big classes that do a lot of things, not single responsibility kind of classes. Those classes usually call the database, call the client, and do all the calculation inside, hopefully in different methods. And those things where the dependency and the actual logic are intertwined, one within the other, are very hard to fake. Because if I'll fake that class, I'll fake away the implementation I care about. We'll start with singletons. This is one implementation of singleton. Being a C++ room, you might find a few problems with it. And that's fine. I'm just trying to make a point. And this singleton has an instance which is initialized exactly once using the call once flag, and a private constructor, just so no one can call new on that singleton. Now, there's two situations when using singletons in code. There's the good way to use singletons, in which I'll implement a singleton and use it outside of the code I care about, and pass that instance as if it is an instance of a class, and no one inside the code should know otherwise, and then I can fake it easily. But in many cases, once I have a singleton, you'll notice people calling it from all over the place, calls throughout the system. The good news with singletons is that if I manage to change the instance, I don't need dependency injection because singleton, in an essence, is a dependency injection, right? If I'll change the instance to something else, every single place that uses that singleton will automatically get my instance. I'll just need to find a good way to do that. And in C++, we have something very powerful that we can use, and it's the friend keyword, which was there forever. By using the friend keyword, I can make sure someone else can call my private methods. And yes, it says that I'm going to change now production code in order to test it. And we'll get to that in a minute. But if we have a singleton, here we go. Here I have, this is the trip service kata. You can find it online in GitHub. I changed the C++ implementation. I'll do a pull request later on. But the idea is that I have two problems. I have a method, get trips by user, very simple method. Here you go. It receives a username, a user instance. And first of all, it checks whether or not I'm logged in. Not the user, but I'm another user. And it checks whether or not I'm logged in using a singleton. User session, get instance, get logged user. Obviously, something bad will happen when I try to test that. If I'm logged in, then I want to get all of the friends of that user and check whether or not I'm a friend of the user I just passed in the method beginning. And if I'm a friend, if he authorized my user, then I'll go to the database and find all the trips of that other user and return all the trips. So I can see if my friend is currently going to Hawaii or something like that. Two problems with this piece of code. The first being the singleton. Who knows what the second one? Anyone? Time to wake up. We have a static method call downstairs here, and a static method call is another problem. This is another form of using something I can't easily fake. And I want to fake the singleton to start with because there are a bunch of tests I can write. But I can check whether or not I'm not logged in. If I'm not logged in, I should get an exception. If I am logged in, but I'm not a friend of that user, that's cool, that's good enough, then I should get an empty list back, right? That's two tests I want to write. And I can do that, because if I write a test, immediately it will call the instance, get a null reference exception, and nothing good will happen after that. Actually, it being C++, probably be some exception happen, please read the code dump. And the solution is quite simple. Without changing the code too much, but a bit, I can go to my singleton class. Over here, this is the singleton class. As you see, the methods are specifically written to throw an exception because I want to make sure I'm not calling those. In the real code, it's probably going to some user session or whatever. And here in the singleton class, I did two things. I did a forward declaration of two new classes, which I'm going to implement in a different place, in the tests, not here, for fake user session that will replace the real user session, and the user session accessor. Couldn't find a better name, sorry. And I made sure that both of those are friends of the singleton class. Having done that, I can now write the fake user session class using Google mock. Here I go, fake user session, has two methods, is user logged in, return a Boolean value, get a user, get logged user, return a pointer to user. That's it. And I'll write another class called the user accessor, which has a single method set that, well, it's up to you what you do. In this specific client, I wanted to make sure that there's no previous instance. And I was a bit lazy. So what I do, I'll call get instance for the instance to get initialized and immediately delete it. Not perfect, but working. And then I'll replace the instance with my instance, and that's it. It's as simple as that, once I allow a few things. And then I'll write my test. Here is the test. Should throw an exception when user is not logged in. When the user is not logged in, I want to throw an exception. I'll create a fake user session, and when calling fake user session get logged in, will return not logged in user, essentially null pointer. And I'll create a real trip service that has no dependency injection whatsoever. But beforehand, I'll make sure that to set my fake user session. Now, every place in the system that calls user session dot instance will get my fake object. Very important when you do those kind of tricks to make sure to clean afterwards. You need to reset that thing after you finish playing with it. And now I can check that I'll get an exception. Assert false means that when the method is called, an exception will be thrown. When get trips by user, I don't care about which user. I'm supposed to get user not logged in exception. That's this test. Second test I can write, that when I'm not a friend of the user, which is fine, then the number of trips returning is 0. And I did it by creating a not user and passing it on, and I make sure that when get logged user will be called, it returns some user which is not a friend of that user. Okay? And I get 0. And those are the two tests I can write. I want to write more tests. Obviously, I want to write the interesting test. The interesting test says that when my user is in fact logged in, then I want to get his trips back. And I did it here. I'll create fake sessions, replace it, trip service. Here we go. This is my friend, and my friend is my friend. He has 2 trips. And when I call get trips by user, I should get the trips back. In fact, that's not what happens. What happens is I'll get an exception, right? Let me run it for you. And hope that nothing bad happens, because demos in a session might be problematic. Where are you? As I said, things tend to interesting. Okay. Unfortunately for us, but this being C++, we can hack our way around using the command line. Do it real quick. Debug. Let's see whether or not in Google Test, when I use it, what I'll end up with is an executable I can run. And this is it. Those are the tests. So I can go here and run trip service test. And I see that 2 tests has passed. Those 2 tests passed, okay, but I get a failure with unknown C++ exception, well, C++ being C++. And so 2 tests passed, 1 test failed, because I haven't done anything about the static method, and which we're going to solve next. Static methods belong to a group called un-fakeable methods. Un-fakeable methods are methods which are impossible to override. Static methods is one of them. How to or impossible to instantiate class are a second one, because I need to instantiate the class, even if it's a fake class. If the constructor calls the database, that is a problem for me. And non-virtual methods. And if I can inherit them, I can fake them. In fact, this is true to any other different static language. C#, VB.NET, Java cannot fake using this method. But C++ can, because in C++ we have a lot of power. And in fact, C++ will enable me to fake unfakeable methods. This is the power I wish I had in other places. And the solution for each is using a kind of duck typing that happens during compilation time. Using template magic, I can create a different class that looks exactly like the class I'm trying to replace. And by using this template class, I can tell him to replace the instance that he's currently using with my instance, and fake unfakeable classes. And I even can fake classes that are internally instantiated without having any other dependency injection. If we go to trip service, by the way, this one is on GitHub, and no, jump to head. What I did here is change the trip service class a bit. I made it a template class. It's a trip service of type T. If this was, in fact, production code, real client, I would inherit it, just so the client would need to define which type is using all the time. But I'll leave it like this. And the T happens here. where I have the static method call. Or in case it's an instance method call but not virtual, the same thing. Basically, even if it was Newt, would work as well. All I need is some type that implements find shrifts by user in order to get compilation to work. And now I can go here and create a fake trip data access object class. Doesn't inherit anything, not virtual. And it has a static method, find shrifts by user, with some dummy implementation in this case. And now I can take this class back to the test that failed beforehand over here. And all I need to do is, is set it to use the fake trips data access object. And that's it. I've just went into the class and replaced whatever happens inside without doing too many changes. I haven't broken anything because the old code keeps on going the same way it worked before. And now this test will pass because it will call the fake trips data object, and that's it. And that's cool. That's something I don't have in any other language other than dynamic language, but there I have many more issues with legacy code than I have here because it's dynamic. And if I'll run the same code again, it passed. If you ignore the errors in the end. This is a Google test trying to save me from myself. And that's it. And I can do that to a multiple kind of methods. In fact, this became my go-to operation whenever I can't easily inject classes. And I can do that in C#. In fact, in C# and Java, what I use is something called extract and override. I'll extract all the logic to a different method and then inherit that class in my test and override the method. But this is much easier. So simpler. Now, some of you might feel that those are not good solutions because I have changed the code. I have changed the legacy code and in order to support the tests. And I have an answer and a story to explain why it's okay. The answer is that I will do anything I can in order to get that code on the test because otherwise I can't work. I can't advance. I can't change it. I can't improve it. And the second one, the story, is that a week ago I was late to work. The reason I was late to work is that City Hall decided that the junction in the end of my street is, we have a big roundabout there with one lane, and they want to change that to a multi-lane kind of junction with headlights and everything. And there was a big tractor blocking the road, and construction workers working there, and I was stuck there for 20 minutes, and I was not happy. And I was stuck there ever since, because they are still doing whatever they're doing there. And I guess it will be like that for a few weeks or months. But I know one thing. As much as I suffer daily right now, in a few months when they finish, my life will be so much easier. I can leave home later because I will not be stuck in traffic, because they will improve everything. And what I have to pay right now is a slight hiccup on the way. In other words, with legacy code, things will get a bit worse before they'll improve. And that's something we need to remember. That's something that you need to explain your boss or your client, because they'll probably be angry at the beginning once you start changing code, writing tests. But after a while, you gain so much confidence and control over your code that you forget it. You forget how bad it was. And I'm sure that if you'll talk to me a year from now, I'll be happy about the way the street turned out to be. And that's something that is very important to remember. There's another very cool thing I can do with C++ and inheritance. Sometimes the problematic method, especially when dealing with very big classes, is in fact a private method. If I have a big class, usually someone who didn't think about solid principle and the single responsibility principle wrote all the logic in a single class. Or as one developer told me when I told him, it's usually the question starts when people ask me, how can I test private methods? It was in Java, but I get it in every language out there. And when a developer asks me about how to test a private method, it turns a small light bulb in the back of my hand. And I ask him, why on earth would you want to do that? And he says, that's because most of our logic is in private methods. When looking at that class, usually what I will find is that the class has some generic name, something, service, utility, whatever. And it has a single public method called execute or run or something on those lines. And all of the logic is shoved into that class. And we get to see those quite a lot. And usually I'll try to explain to that developer that you need to refactor that class, break it into different classes. Last time I did that, I got an answer, very problematic answer that made me laugh inside because you don't want to laugh in front of your client. He told me, my team leader does not believe in breaking things into classes. So good luck with that. But even if I do believe in classes, this abstract mythical creature, sometimes I need to test this thing before I break it into classes, right? And so I have this private method that's saved to a database, and that's a shame. And I want to fake only that method. And in C++ I can, because all I have to do is inherit that class and declare all the classes public, and that's it. I can change the accessibility of methods in C++ by inheriting that class. And I can fake the private method, the protected method, the public, whatever I want. And this way, and it's not a healthy situation to be in. But once I get this class under test, the parts that I haven't faked, I can break it up to different classes. At least I have the confidence that whatever worked before will continue on working. And you can do that with any other language out there, just C++. So that's a cool thing. So, to summarize, taking control of the legacy code. We have a legacy code situation which is not a perfect place to be, but unfortunately most of us get to see that from time to time or all day long. So first thing we need to do is to write a few tests. Understand what the code does through your code. Document the code through your code. And then once I have a few tests, I'll probably hit a brick wall, the brick wall being dependencies. And then I'll get to employ those fake objects, those mock objects, in order to test without those dependencies. And once I have that in place, I can replace the actual dependencies with my classes that does what I tell them to do. And I can refactor and clean up the code. Now, a few words about refactor. There are a few definitions for refactoring. There's the right definition being, I'll change what the code does I change how the code does something without changing what the code does. The second being, I want to rewrite the code, but my boss won't allow me, so I'll call it refactor. I'm not talking about that one. But you can, once you have tests in place. And once I have all of those, well, lucky me, I have maintainable code. And this is a process that will take something between a few weeks to a year or so, depending on your code. But you'll get there as long as you persist. And be certain that what you're doing is, in fact, improving the code. That was my session. Thank you very much. By the way, if you would like to learn more about unit testing, come tomorrow to my session, and you can also go to Pluralsight. I have a few of those here if you need a few weeks there, because I have 2 courses there which are more extensive than 1 hour talk. And if you have any question, I'll be happy to answer them right now.